For a question like this, I would expect you to write some work and not just go to your calculator. Now, the first one for us is pretty obvious. We have 2/9 and we have 7/9. So altogether, we're going to have 2 plus 7 or 9/9, which we could write as 1. And so there's not much work to write. And this is what I would enter as my answer. The next one, I have tenths and 14ths, and that one isn't so obvious. So my work would be to find a common denominator, and I have two options on how to do that. So I could show the LCD method on that one, where I would factor 10 as 2 times 5, and 14 would be 2 times 7. And so the LCD is going to be 2 times 5 times 7. 2 times 5 is 10, times 7 is 70. And then I need to adjust my fractions. So the 10 is missing a 7. And the 14, which is 2 times 7, is missing the 5. So for my 9/10 plus 3/14, I'm going to adjust the 10, which is missing its 7 multiple to get 70, and adjust the 14, which is missing the 5. So that's going to give me 9 times 7 or 63. 70ths combined with 3 times 5, 15 70ths for a total of 60 78 70ths. And then I can see they're both even. And so one strategy would be to find the greatest common divisor here. Or you could just notice they're even and divide by 2. Maybe 2 is the greatest common divisor. We don't know until we find it. But 2 is pretty easy. 2 goes into 7 3 times with 1 left over. 2 goes into 18 9 times. 2 goes into 70 35 times. 39 is divisible by 3. 35 is not. 35 is divisible by 5, but 39 is not. I'm guessing it doesn't reduce anymore, and I would say that would be my reduced answer, because I don't see a common denominator. If you weren't sure about reducing that, then again, the best way, I like reducing one factor at a time, but you could find the greatest common divisor, 78 and 70. We used a couple methods to do that. Factor tree would be one way to do it. Euclidean algorithm would be another way to do it. Listing all the factors would be another way to do it. So let's see, which method do I want to use? I'm going to use the factor tree method. So 78 is 2 times 39. 39 is 3 times 13, and I'm done. 70 is 2 times 35. 35 is, oops, not 3, 5 times 7. And the only common factor they have for primes is 2. So it turns out that's also the GCD. And so I guessed correctly up there. And that is the reduced version of this answer. So I would enter 39 35ths. Next one, I can see that 5 goes into 10, so that one's pretty straightforward. I'm just going to multiply top and bottom by 2 here, and that gives me 7 plus 4 tenths for a total of 14 tenths, which can be reduced. So 2 goes into 14 7 times, 2 goes into 10 5 times, and there's no more common denominator, so I would state the answer as 7/5. Now, some people might say, well, that's not reduced because 5 goes into 7. Well, it does and it doesn't, right? 5 does go into 7 one time with a remainder of 2, but that's a mixed number, 1 and 2/5. Is that really simpler than 7/5? So I would argue 7/5 is actually a simpler representation of that number.
Is 7 plus 4 is 11, not 14?
Oh, shit. Good job. All right, so this is incorrect. 7 and 4 is 11. Oh, I must have looked at the 4 and the 10 when I found that. Thank you so much. So it's 11/10, which does not reduce. So I would say 11/10 is the best possible answer there. And again, I would prefer an improper fraction than a mixed number here. For this problem, let's see, click on the box, slightly different set of numbers. Enter a reduced mixed number, proper or improper fraction. So I can enter it a variety of different ways and it'll take the answer. So I prefer stopping at the improper fraction, but I could also enter it as a mixed number. 10 goes into 11 one time with 1 out of 10 left over. So I would expect when you do your homework, you write down that much work. And if this is a test question, then I expect you to turn in at least that much work.